Today, I want to take you through an exciting project I've been working on that combines two powerful domains: generative AI and mental health support. I recently published a detailed Python notebook on Kaggle and a corresponding blog post that discusses how large language models like Gemini can be leveraged to create a mental health analysis and support system. Mental health is a critical global priority. Yet, the access to the quality support remains very challenging for many. In this video, I'll walk you through how modern generative AI technologies can offer promising new approaches to address this gap. So, this project demonstrates how generative AI can assist in analyzing text data to identify mental health concerns and provide appropriate support responses. The system I have built addresses several key challenges faced by traditional mental health support: limited availability of mental health professionals, delays in identifying concerning patterns in communication, need for consistent evidence based responses, privacy and personalization requirements. System performs six critical functions: analyzing text data to identify potential mental health concerns, categorizing the type of severity of concerns, generating appropriate empathetic responses, providing evidence based information from reliable sources, maintaining contextual awareness for ongoing supportive conversations, and finally, executing a defined workflow for handling user input. So, some key generative AI capabilities. This project is particularly interesting in how it leverages several advanced capabilities of modern generative AI systems. So, let me walk through a few. Firstly, we are using RAG, or retrieval augmented generation, to provide evidence-based mental health information. Rather than just generating responses based on model training, the system retrieves relevant knowledge from mental health literature before generating responses. Secondly, we are using few-shot prompting by carefully crafted examples of appropriate mental health responses. This helps the model generate specialized and empathetic responses tailored to different mental health concerns. Thirdly, we have implemented a structured output or JSON mode to systematically categorize and analyze mental health text data, enabling more accurate assessment of concerns. Fourthly, we leverage the long context window, which is one of the capabilities of Gemini, to maintain coherent and contextually aware supportive conversation. Fifth, the system performs document understanding to analyze and extract insights from mental health literature, enabling evidence-based responses backed by established knowledge. And finally, we have implemented a agentic workflow with LangGraph, which orchestrates the analysis, retrieval, and response generation process in a defined sequence. So let's look at some of the data sources we have used. So for this project, I've utilized three data sets which are freely available from Kaggle. The first one is the Mental Health in Tech survey. It contains survey responses about mental health in tech work in tech workplace. The data shows an almost equal distribution between those who have sought treatment and those who haven't, as well as different levels of work interference due to mental health issues. The second data set is the mental health corpus, which contains posts from mental health support forums with binary labels indicating mental health concerns. This dataset has an almost balanced distribution between non-concerning and concerning posts. The third dataset is the suicide prevention dataset. This contains text data related to suicide risk identification. This is a very large dataset and has an equal distribution between suicide-related and non-suicide-related texts, which provide valuable insights for identifying the high-risk content. So let's look at the system architecture. So the mental health analysis and support system is built with a very modular architecture. So first, we have text preprocessing that cleans and prepares text input and analysis. Next is the mental health analysis, which analyzes text for potential mental health concerns. Third, we have a concern assessment that evaluates the type and severity of detected concerns. So based on this assessment, the system generates a specialized response in if concerns are detected or provides a general support response if no concerns are found. So for specialized response, we use evidence retrieval to get relevant information from mental health literature. And finally, all this comes together in the final response formulation, which combines analysis and evidence into a coherent, empathetic response. So one of the most innovative aspects of this project is the implementation of LangGraph, which allows us to create a structured workflow with specialized nodes. The workflow has four key nodes. Analyze input node that uses Gemini's structured output capability to analyze text for mental health concerns. A routing node that decides whether to retrieve information based on analysis results. A retrieve information node that uses RAG to find relevant evidence-based content, and a generate response node that creates the final supportive response using analysis results and relevant context. So this structured approach ensures very consistent handling of mental health concerns with appropriate routing based on severity and context. So let's look at some of the implementation details. So this project is implemented with Google Gemini 2.5 Pro preview model. So I've kept the dependencies minimal, leveraging Kaggle's pre-installed packages where possible and adding only essential libraries. For mental health analysis, I've defined structured schema. Um, uh, I've to ensure that we return comprehensive assessment of mental health text. This schema captures the primary concern, severity level, support needed, key themes, safety concerns, and analysis summary. So So let's look at um, the response generation components combines few shot prompting RAG within an agentic workflow. So I've carefully designed a prompt template that instructs the model to be empathetic, avoid diagnosis, and prioritize safety in crisis situations, and to naturally incorporate relevant information. So let's look at the results from this system. So the system achieved high accuracy in identifying posts with mental health concerns with over 85% agreement with human annotations. So responses were evaluated for empathy, accuracy, helpfulness, showing strong performance across these dimensions. The system incorporated relevant evidence-based information in its response, and the Landgraph implementation demonstrated reliable routing and processing of inputs based on concern severity. So let me show you a quick example. So, so uh, here is an analysis of a text from the mental health corpus identifying depression of moderate severity, recommending professional help, emotional support, and coping strategies, and noting key themes like low mood and anhedonia. So here are some of the ethical considerations. So it's crucial to acknowledge the limitations uh, and ethical consideration of such a system. So this is definitely not a diagnostic tool and should never be used to diagnose mental health conditions. So mental health analysis based on text alone has inherent limitations. So this system does not fully account for cultural differences in expressing mental health concerns, and performance depends on the underlying AI models and data quality. So from an ethical standpoint, we must consider privacy and data security for high sensitive mental health data, transparency about users interacting with an AI system, harm prevention with safeguards for crisis situations, and the necessity of human oversight, especially for high risk situations. Ongoing evaluation of potential biases is key, especially when it comes to demographics, culture, and language. So in the future, I would like to consider incorporating multimodal analysis of voice, facial expressions, and other signals for more comprehensive assessment. We could, of course, further adapt this system to individual user preferences, history, and needs. We could also develop systems that augment rather than replace human mental health providers, uh, implement longitudinal analysis to track patterns over time, and then incorporate more diverse and recent research in mental health. So finally, this project demonstrates the potential of generative AI to address significant challenges in mental health support systems. So by combining advanced capabilities like RAG, few-shot prompting, structured output generation, agentic workflows, we can create systems that provide more accessible, consistent, and evidence-based mental health support. It's important to emphasize that such AI systems cannot and should not replace human mental health professionals. Rather, they offer a promising complementary approach that may help bridge the significant gap between mental health needs and the available resources. As we continue to develop these technologies, maintaining a focus on human centered design, rigorous evaluation, and ethical implementation will be essential to realizing their potential benefits while minimizing risks. So, if you are interested to learn more, check out my IPython notebook here um, on Kaggle, and obviously the blog post you saw. And thank you for watching. Love to hear your thoughts and your comments. Um,